Okay, so this chapter talks about the measurement of the angles. So you see that the first concept is this one, the ray. The ray is a line where you have the starting point at, let's say, x, and then it goes after the g. So then you can write ray xz, or you write xz without the ray. You write this like this, or you write like this, ray xz. Okay, the next concept is opposite rays. Opposite ray is that you have a line here. You're seeing this line here. So it has a point X. So point X and the opposite sides, you have 2 points, Y and Z. So they are opposite. So one ray is going in this direction, another ray is going in this direction. So they are basically collinear. You remember the collinear concept? It lies on the same plane. It lies on the same line. That's why it is called collinear. And they are exactly opposite. That's why it's opposite rays. So now why we are telling this? Because we have to form an angle. So the criteria to form an angle is you should have one common endpoint, and then you should have two lines which are non-collinear. When I say non-collinear, means they are not in the same plane. They are going in opposite directions like this. Like they are non-collinear. These points are not lying on the same line. This point A lies on this line. This point C lies on this line. And then when they have the common endpoint, then the angle will be formed. This is the concept of the angle. So then the angle will be ABC. That's what will form the angle. So now we have three types of angle. So this is a little tilted, but this has to be exactly straight. The right angle triangle will be notified by this symbol. This is right angle triangle. Then we have the acute angle. So you see right there, this is less than 90. That's acute angle. The obtuse, it is more than 90. That's not exactly 90, it's more than 90. That's it, obtuse. Now, with the help of these three, we're gonna learn about the congruent angles. The congruent angles are like you have this line, right? See, simple. You have this line, ABE. Now this has got two angles. So one way is that you draw a line. So you see that angle A, B and C. And then you see angle D, B and E. These two angles are same. These two angles are same. Now based on that, they are the congruent angles. Now, because these two are same, then there is an analogy that the angle C, B and E and the angle A, B and D will also be the same. I'm talking about this angle and the other side, this angle, they will also be same. That's what is called congruent angles. This is with the one line. But what if you have two? So let's say you have one line, which is, let's say, D and C, the line DC, right? So you have two lines here. The one is EF, the another one is BA. So now the angle that you are seeing here, D, E and F, and the angle that you are seeing here, A, B and C, these two angles, this one and this one, these two angles are same. So now there's a property for congruent that these two angles are same. This means that the other angles F, E and B and A, B and E will also be same. See, it's a very simple terminology. This whole has to be, if it's a straight line, right? You see here it's a horizontal line. The full angle, this one and this one, they'll be sum up as 180, right? There'll be the sum of this is 180. It's a horizontal line. So now let's say you take out 60 degree here, then you left up with 120 here, okay? And then let's say you have another 60 here and this, then you, of course, you're gonna have 120 here because it's a horizontal line. So what we can deduce? We can deduce that if angle ABC equals angle DEF, which is here, if angle A, B and C is equal to angle D, E and F, then angle AB will also be equal to BEF. So where we have that A, B and E, this angle will also be equal to B, E and F. This one, very simple.